Welcome back. Let's talk about unconformities. So based on the 6 principles of relative dating, principle of superposition, lateral continuity, etc., you can look at a sequence of layers of rocks and really begin to tell the story. You really need to know very little other than maybe the types of rocks you're looking at, sediment, igneous, and metamorphic. From there, you can say, oh, this happened, and this happened, and this happened. That's a pretty powerful thing to be able just to go, yeah, this, and then this. However, sometimes when we're looking at these sequences, weird things happen. And that's how I kind of describe what are known as unconformities. So remember, uniformitarianism, say it with me now, uniformitarianism is that what we see happening today also happened in the past. The present is the key to the past. Present-day processes have happened throughout geologic time. This was developed by James Hutton. You heard about him last section, as well as Charles Lyell. These are some other big names in geology. Although William Whewell, what a name, he actually came up with the term uniformitarianism. It's kind of a side note, but James Hutton and Lyell, kind of came up with this idea like, hey, you know what? This stuff has been going on since Earth's been around. That's going to help us explain the Earth's history, Earth's past. Because, again, Hutton understood that geologic processes have occurred over long periods of time, and they take long periods of time. So we need an Earth that's old. At this point, we still don't have an absolute age of the Earth, but we can see these processes and kind of put them in order and know Earth should have been around for a long, long time. Today, again, as geologists, we assume these same processes and laws of nature are constant, but we know that the rates have changed. How fast plates move around might speed up, might slow down, depends on a number of factors. That's just an example. But we know rates have changed. But the processes have occurred throughout time, and those principles of relative dating hold true. However, again, sometimes the unexpected presents itself that tests the validity of those principles, but if the principles hold true, then we know we're on the right track. So I introduced you to, I believe it's pronounced Sicker or Sikar Point in Scotland. All right. So this is a very famous outcrop of rocks. James Hutton was here, and he's kind of looking at these and like, wait a minute, there's some weird stuff going on. So I got these layers of rocks kind of going this way, and I got these layers of rocks that are pretty much vertical. So I got these layers of something weird's going on here. Something weird. Something's changed. Okay, I get that these aren't horizontal anymore, they're vertical. But all of a sudden, we get this other stuff going on here. What the heck's going on? So this is an example of an unconformity. So again, I like to say something weird's going on and there's missing information. So kind of looking around at this, so we have these kind of tilted sedimentary rocks. These were deposited, the sediment for these are originally deposited in the desert 345 million years ago during the Devonian period. Above this red line, below the red line, we have these vertical sedimentary layers. Well, one, we know they were horizontal, so they've had to be kind of tilted up. And they contain marine fossils, so we know that the sediment was deposited in the deep ocean about 425 million years ago. That's during the Silurian. And in between those two, there's a gap in time, about 90 million years. So in that gap of time, that's what we call this unconformity. So we have this unconformity. There's a break in history. There's something missing, a period of non-deposition or active erosion. There's just either all the information was ground down, it's missing, something weird happened, different processes occurred. Whatever tilted up these layers of rocks stopped happening, and then sediment was deposited. Because also, these sedimentary rocks originated as sediment in the deep ocean. However, these particular types of rocks was sediment deposited in deserts. I don't know, but oceans and deserts, these are two different things, two different time periods, separated by this gap in time, known as an unconformity. Something weird happened, processes changed in this area. That's what an unconformity is. So Hutton, again, applied the principles of the principle of uniformitarianism. So what happened in the past happens in the present and vice versa when interpreting the rocks at Sikar Point. He explained that the tilted lower rocks resulted from severe upheaval that formed maybe mountains, maybe some sort of convergent boundary, and these were kind of then ground down and covered by those younger flat-lying sediments and sedimentary rocks. And that erosional surface between the two, that gap in time, represents a gap in the rock record known as an unconformity. We now note and call what Hutton saw an unconformity. He didn't come up with that, but that's what he was seeing. But he properly interpreted everything based on the principles of stratigraphy. So the principles still hold, and we can still explain everything, even though we get these weird things happening, these changing processes, this missing time. We can't necessarily, figure out exactly what happened in this missing time, but we know it's missing. So principles still hold true. So again, unconformities are gaps in the geologic record that may indicate crustal deformation, weathering and erosion, and or sea level variation. So these unconformities indicate a change in processes, stuff added, stuff removed. There's this gap in time. So they represent, again, when deposition stopped, an interval of weathering and erosion removed some previously deposited rocks, so it just kind of erased layers that were already there, and then deposition occurred again. Something weird happened. There's missing information. That's called an unconformity. And there's three types of unconformities, and we'll talk about each. There's a disconformity, there's a nonconformity, and an angular unconformity. Disconformity is an erosional surface. So there was material, but it was weathered and eroded away. So it's called an erosional surface, something that got ground down and material taken away. So there's an erosional surface between two horizontal sedimentary rock layers. That's important. So these are two different types of sedimentary rock. The unconformity is here. All right. There's some missing information here. We get one type of sedimentary rock, we get a different type of sedimentary rock, and there's a gap in time. Well, how the heck do you know there's a gap in time? How do you know it just wasn't one and then the other? It's hard to recognize. Fossils help. Using that principle of fossil succession, maybe you find some fossils here that are 400 million years old, and here you find fossils that are 300 million years old. Wait a minute. There's a gap of 100 million years missing there. Where did that go? This lower material, it was there at one point, but then weathering and erosion ground it down to an erosional surface, so it took some of that material away, took 100 million years of history away, geologic history away, and then new sediment was deposited on top that eventually formed sedimentary rocks. So disconformity, missing information between two layers of sedimentary rock. Nonconformity is missing information between younger sedimentary rock on top and older igneous or metamorphic rock below that also has an erosional surface. Those are different processes. So you have some sort of metamorphic rock, usually formed by convergent boundaries, heat and pressure, or igneous rocks, an intrusion of magma or lava flows, and either of those that were ground down, so you have now erosional surface, and then sediment deposited on top that eventually would form sedimentary rock layers. These are change in processes with a gap in time, different rock layers, that's known as a nonconformity. So missing information between older igneous or metamorphic rocks below and younger sedimentary rocks above. Disconformity, sedimentary. Nonconformity, sedimentary, metamorphic, or igneous rocks. And then the third is an angular unconformity. This might be the easiest to recognize. So we have another one of these erosional surfaces. Something was weathered and eroded down to leave what's known as an erosional surface. So there's missing information between what we have as this younger horizontal sedimentary rock above, and we have this tilted sedimentary rock below. All right? So we have this horizontal sedimentary rock above and this very much tilted and folded sedimentary rock below. The rocks below are angled and they've been weathered and eroded, ground down to a flat erosional surface. new sediment deposited on top that eventually forms sedimentary rock. Again, probably the easiest to recognize because you got tilted stuff below, horizontal stuff above. Angular unconformity. Just for reference, to show you the size, here's a human being right here. This is some big tilts and folds. So it looks like in these sedimentary layers, perhaps metamorphic layers, maybe near a convergent boundary, things were kind of folded up via deformation. Originally they were horizontal, and then maybe a convergent boundary kind of folded them up. Weathering and erosion ground those down to a flat surface, new sediment deposited on top that would eventually lithify and turn into sedimentary rock, which is kind of what we see here. So originally you get some layers deposited, principle of original horizontality. They were later tilted due to some deformation, maybe convergent boundary. The top of it was ground down to an erosional surface, and then new sediment deposited on top that would eventually become sedimentary rock layers. So there you have an angular unconformity. Horizontal above, tilted below. Pretty easy to pick out. Going back to the Grand Canyon, I mean, not only is there spectacular history throughout time, there's also a number of unconformities in the Grand Canyon. We have disconformities, so missing information between two sedimentary rock layers. There's another disconformity. We have nonconformities, missing information between sedimentary rock layers and, in this case, metamorphic rock layers below, or igneous rock layers over here, so sediment igneous. And then we also have an angular unconformity. We see above this material is horizontal, below it is tilted. That is an angular unconformity. And there's actually something cool, very special about this angular unconformity. We actually gave it a specific name, and that angular unconformity is called the Great Unconformity. So again, we see it down here. Horizontal above, tilted below. It's an angular unconformity, but we just name it the Great Unconformity. It is a very dramatic boundary of a huge gap in the rock record in our understanding of Earth's history. And the crazy part is it happens in different rock layers almost worldwide. There's just this gap of missing information. And depending on where you're at on Earth and what you're looking at, there's anywhere from 1 million to 1 billion years of missing information, depending on where you're at in this great unconformity, because we find it a number of places around the world. This was named, obviously this is in here in Arizona, in 1869 by explorer and geologist John Wesley Powell, famous in Arizona history. During his first documented trip through the Grand Canyon, he was the first person to take a one-person boat down the entire Grand Canyon, and I think he only had one arm, too. So one of the hypotheses about what could have caused the Great Unconformity was snowball Earth. That at one point in Earth was totally covered by ice, about 720 to 635 million years ago, and as that ice moved around, it weathered and eroded all of this material. Hence, there's this gap in time depending on where you're at around Earth. All of that material would have been kind of deposited, all that mineral material would have been deposited in the ocean. So that could explain the Cambrian explosion, all of a sudden this diversification of life in the ocean because all this tremendous amount of nutrients and minerals got dumped into the ocean. So that's a hypothesis, which is an educated guess based on some information. That's not a theory, right? This is still kind of just maybe a little bit of an educated guess at what was going on. Or hypothesis number 2, there was just some large-scale erosion and weathering, and that was driven by the formation and separation of some supercontinent. When the Earth cycles through supercontinent formation and separation, there's uplift, there's weathering, there's erosion to great areas of rock all around the Earth that exists at the time. So maybe that caused this weathering and erosion process to happen. Okay, so what we can now do, and we'll probably look at some of this stuff in lab, is look at sequences like this and begin to put these together relatively. This happened first, this is the oldest, then this, then this, then this, then this, then this, then this, this, and this. It looks kind of crazy and complicated, but I think in lab we'll probably tackle some of these, and you can tell a story of a cross-section of Earth just kind of by using some of the principles of relative dating. So let's go ahead and pause there. When we come back, we'll talk about absolute dating. See you back here in just a second.